All right, a student that I was tutoring was having trouble with this problem. They didn't really understand this at all. They had no idea where to start. They didn't know they didn't balance the equation correctly. They didn't know what experiment yield was. They didn't know how to use this information down here at all. And so rather than just explain how I would solve it in an expert point of view from straight to finish using all these conversion factors, I kind of slowed down and helped them understand ratios and equivalencies and how the balanced chemical equation can really give you all of this information in a very, very easy way, in a much better way to understand this, okay? So if you're just starting out with theoretical yields, this video might really help you understand very simply how this is occurring. Okay, so what we want to do here is step one. We want to balance the chemical equation. That's the absolutely first step you need to do. If you have a balanced chemical equation in your homework or in an exam, double check it. Your professor could make a mistake. The authors of your textbook could make a mistake. And so let's take a look here, okay? We have methane, water, carbon dioxide, hydrogen. Okay, you might not remember those chemical names, so I'll just refer to them by their formulas from now on. Now, don't start with hydrogen. Hydrogen's in 3 different spots. It's the hardest thing to balance. Start with the simpler elements first. For example, carbon, we have 1 here, and we have 1 here. So that appears to be balanced. Next, look at oxygen. Okay, this formula over here has 2 oxygens. This formula right here has 1. Okay, so there's 2 O's here, and there's 1 O here. So we need to put a 2 in front of this H2O. If we multiply this whole thing by 2, we're multiplying the number of oxygens by 2. And now we've got 2 oxygens on the left and 2 oxygens on the right. Now let's turn our attention to the hydrogen. This chemical formula right here has 4 hydrogens. Okay, H2O, we have a 2 in front of it. So 2 times 2 is 4, so we have 4 H's here as well. So on the left-hand side, we have a total of 8 hydrogens. Okay, that's quite a few. And we look on the right, and it comes in packages of 2. Okay, so in order to get that to be 8, we have to multiply this by 4. Okay, and so we do that by putting a coefficient in front of the H2 molecule. Okay, a 4. All right, so that's how you balance this chemical equation. Now I'm going to erase this this business here, so we have a little bit more room to work with. Okay, and the first thing to think about, okay, I asked this student, was what do those numbers mean? What do these coefficients mean? And she told me, well, it means 1 molecule of this reacts with 2 molecules of that, you know, to give 1 molecule of CO2 and 4 molecules of hydrogen. And I said, yeah, that's true. And what about moles? And after some talking, we decided that, you know, 1 mole of CH4 will react with 2 moles of H2O to give 1 mole of CO2 and give 4 moles of hydrogen. Okay? And I asked her, well, what's a mole? And she said the 6.022 times 10 to the 23rd thingy. And I said, well, yeah, but how is that related to grams? And we looked at the periodic table and we did a little review on figuring out molar masses. CH4, for example, has 1 carbon and 4 hydrogens. Okay, and so what you do is you take these numbers from the periodic table and you multiply them by the subscripts in your chemical formula. So that's why we're multiplying carbon by 12.011 by 1. And we're multiplying the hydrogen number here on the periodic table by 4. And we get 4.032. Okay, and we add this all up, and that's going to be the mass of 1 mole of the methane in units of grams. Okay, so I'm going to put a little equal sign going down the page. You know, a TA or a professor wouldn't like the demonstration of that equal sign going up and down, but we know what that means. 1 mole of this chemical is equal to that mass. And we don't need H2O here. H2O is not mentioned in the problem at all. So we don't need to work on that, nor do we need to work on CO2. Now hydrogen's mentioned. That's the thing we're synthesizing, we're making. So for hydrogen, keep in mind it's not just 1.008, it's H2, okay? So we multiply this number by 2 on the periodic table and you get that 2.016. Okay, what are the units there? Grams per mole. So 2.016 grams of hydrogen is equal to 1 mole of hydrogen, okay? Is equal to 1 mole of hydrogen. Now, here we have 4, right? We have a 4 here. Let me switch back to the purple pen, okay? There are 4 moles of hydrogen produced by 1 mole of methane, okay? So 1 mole of methane is just straight off that number on the periodic table, okay? 4 moles of methane is where we got that number 4 there. But this number here in the box is the number for 1 mole of H2. So we want to take this number that we calculated, okay, from the periodic table and multiply it by 4 to calculate how much mass is 4 moles of H2. Okay, so what I get on my calculator, we'll do that together, hopefully you're following along with your own calculator, is 8.064. Okay, 8.064 grams. Okay, we're doing it this way so you can understand the concept. Okay, it's maybe not the most clear. Once you understand the concept, then you can represent the math a little bit better, okay? So this balanced chemical equation tells us that 16.043 grams of methane will react, right, and form 8.064 grams of H2, okay? Can you solve the rest of the problem yourself? Maybe not. There's a kilograms here, okay? Kilograms here as well. So let's convert these to kilograms, okay? Remember, to go from grams to kilograms, you divide by 1,000. So let's do that on our calculator, just to make sure we don't mess up with the decimal place. Okay, and what I get here is 0.0160. And some other numbers there, but I'll just leave that off. Kilograms of CH4, okay? And if I convert that to kilograms, it might just be easiest just to write 8.064 times 10 to the minus 3, okay? And that's kilograms of H2, okay? Now we're getting somewhere. Now we're getting something very close to the final product, the final, you know, numbers in this answer, okay? So they're saying they don't start with this mass, they're starting with 64 kilograms, okay? And this amount right here is what we call the theoretical mass, okay? And they're not getting that, of course, they're getting this, okay? So now we have things in very close units to the problem. These two are equivalent, okay? These two are equivalent. I'm going to put a huge equal sign here because we know that 0.16 kilograms of CH4, okay, is equivalent to 8.064 times 10 to the minus 3 kilograms of H2, okay? And that's once again related back to the balanced chemical equation. Okay. Now, what we want to do is calculate the theoretical yield. All right. This step right here would take quite a bit of work, but we've done all the work kind of vertically here. So what we have is 64 kilograms of CH4. Okay? And we're going to use this equivalency to set up the conversion. Okay? So down below, I'm going to have 0.016 kilograms of CH4. And up on top, I'm going to have 8.064 times 10 to the minus 3 kilograms of H2. Okay, the units here cancel, and let's go ahead and punch this in our calculator. 64 times 8.064, 10 to the minus 3, divide 0.016. Okay, hit the equal key, and what I get there is 32.26 kilograms of H2. Okay, so that's the maximum theoretical amount of hydrogen that I could make. I could make a whopping 32 kilograms of H2. All right, now in this word problem, they've only made 12.8. Okay, so this is where you do the theoretical yield. Okay, your percent yield is what you get in your experiment or at the factory divided by the maximum theoretical yield. Okay, in the experiment or at the factory, they've got 12.8 kilograms, and what we got maximum is what we calculated anyway, is 32.26 kilograms. Okay, go ahead and multiply what you get on your calculator by 100 to move the decimal over, and we'll do this on our calculator, and I get multiply by 100, I get 39.7% yield. Okay, so it's a little bit of scratch work and scribbling and so on, but I hope this presentation helps you understand the concept a little bit more. This balanced chemical equation tells you 1 mole of CH4 forms 4 moles of H2. Okay? Or if we use the periodic table, 16 grams of CH4 is going to be equal to 8 grams of H2. We divide both of those by 1,000 to give us this similar equivalency. 0.016 kilograms is equal to 8.064 times 10 to the minus 3 kilograms of the other chemical. And then we do the conversion with just one conversion factor to give us the theoretical yield of hydrogen. And then your percent yield is your actual yield from the experiment divided by your theoretical maximum yield. Okay? And the final answer here is 39.7% yield. I hope this unique way of presenting theoretical yields kind of helps you understand this in a better light. Thank you for watching.